Whether, I mean, it could be personalization if it's a system that's interacting with a human being, or just adaptive if it's a system that's interacting with machines.
Mhm.
But either way, it gives you a level of flexibility you didn't have before these latest incarnations, these generative models came into being. You couldn't do that with just machine learning in the prior age. Well, you can do that now.
Welcome to the Risk Never Sleeps podcast, in which we learn about the people that are on the front lines protecting patient safety and delivering patient care. I'm Ed Gaudet, the host, and today I am pleased to have Keith Deutsch join us, a fractional CTO and a lifelong tech journeyman. That sounds odd, doesn't it?
Journeying and journaling.
Journeying and journaling, and right. I love your background, Park. Wow, we're going to get into a lot today. I
spent a little time on that.
Yeah, and you have a lot of experience, and I know you're probably got your arms deep into AI. So let's start with, tell our listeners a little bit about yourself and your current role.
So these days, throughout the last couple of years, and to be honest, I fell into this completely accidentally. I was as much a surprise to me as anybody else. I woke up one day and said, I guess I'm doing this. I've been what they call these days a fractional CTO. Now, again, 2 years ago, I didn't even know the term fractional, but that appears to be a mode of operating that's increasingly common. So I work with several companies. I'm not direct with any of them. I'm, as they say, fractional. These tend to be early stage companies because you mentioned Park, and we'll get into how that fits into that paradigm in a minute, or several minutes, whatever. But my background is largely early stage companies. I've been involved in an almost pathological number of startups and early stage companies, and that can be anywhere from, one or two people with an idea to maybe a couple hundred people and an MVP they've introduced, and now they're figuring out where to go next. I have co-founded a couple of companies, and as I said, I've worked with maybe more than 30 early stage companies over the course of my career. So these days I'm doing it on a fractional basis, and the thing that ties these companies together more than anything else, you mentioned, the AI part, is a pragmatic need to do something around, I think of it as agentic architectures. And prior to that, I'd been more of a domain-driven thing. I'd been in IoT and I'd been in health tech. But these days, it's less about the domain and more about, I've got this notion of something that I think I can do better using these new technologies. How do I do it? So that's been what I've been doing for the last couple of years.
Give us some learnings, like what, on this journey with AI and agentic, what has been the most interesting thing that you've learned?
Well, so there's a lot of, and this has been a passion for me also developing over the last couple of years. And when I talk about pragmatic, quote unquote, AI, first of all, I should be full disclosure. I don't like the term AI. To me, the best definition of artificial intelligence is a poor choice of words in 1954. Guy who came up with that term came up with, But these generative models are transformational. They can enable. I mean, they're great for chatbots. Yes, I use them as a research assistant. They're wonderful. But from a platform building standpoint, they are transformational because they allow you to build a platform that can do things that you really couldn't practically do before. And you do this using these things called agents. But the thing you were asking me, what I've discovered, what is the surprising thing, is just how poorly understood this technology is. So much of what people see going on around it is the engineering, the sort of classical software engineering to leverage these tools, not the tools themselves. And because I've been building these platforms, I see this. The way you go about thinking about this stuff is not what you would assume given the hype around AI. And I try to clarify that to somewhat in some articles I've been writing, which you're welcome to go read.
So people are more focused on the integration capabilities versus the let's open up the hood, let's get in there, let's really understand how these things work and how to leverage these in a more precise way.
You kind of have to know how they work in order to make use of them. And that's been an exercise of the last few years of diving into just exactly how these things actually work. But the way you leverage them, and you pretty much use these models as the generative model can be fairly generic. You don't have to, you don't need data. They don't learn. They're just there. And they do a certain kind of reasoning in a flexible way that you couldn't do before. So now you can write software that builds very elaborate contexts and have something that once you've built this thing, you can sort of give it to it and say, so what do you think? Do I need to add more to this? Oh, you think so? Okay, I'll go add more. And I'll go do some searches or whatever, pull some more data and build a context iteratively. So it's not one step. You are iteratively building this context using an agent, and you're using the reasoning of the LLM to say, look at what I've got so far. Is this complete? And it can actually do that. You come back and say no. And finally, when you're done, it can render whatever you've done as a finished document in a way that wasn't possible before. And that's radical. That allows you to build a level of personalization, a level of adaptivity into whatever the system is. It could be personalization if it's a system that's interacting with a human being, or just adaptive if it's a system that's interacting with machines. But either way, it gives you a level of flexibility you didn't have before these latest incarnations, these generative models came into being. You couldn't do that with just machine learning in the prior age. Well, you can do that now. But it's not magic. It is craft. You're not really, changing. When you build one of these systems, you haven't built a new AI. The model you're using is probably an off-the-shelf model that somebody else trained in some major, in some heavyweight process. You're building the agentic architecture that consumes this thing and does something useful with it.
And with that opportunity also comes risks. So when this goes off the rail, why?
So some of that is poor engineering. You hear a lot about hallucinations. If you and you can see this, by the way, just
what's a hallucination for the casual listener that's on?
Okay, so there is, I'll use another word that probably I shouldn't use in a casual way, a stochastic element to a neural network. Any neural network, particularly something as large as these LLMs, they don't have a completely deterministic result, and they are operating in such a large network of possibilities that if you're not really careful, forget LLMs. Talking to you, you have this thing in your head called a brain.
I like to think so, although my wife would argue.
Well, I'm going to give you credit for having one.
Thank you, Keith.
That brain is much more complicated than any LLM ever built, by orders of magnitude. And if I'm talking to you, if I'm not real careful about how I frame things to you, you'll latch onto the wrong thing. And it's not, the term hallucination is used here in terms of it, but it's not a hallucination. You just simply, you said X, Y, and Z. This is what I think X, Y, and Z is. And I haven't been careful enough. And so you go in the wrong direction. Now, if it's just conversation between us, it's correcting. I say, what are you talking about, Ed? I didn't say that.
So it's an inference issue.
It's an inference issue. You go off on the wrong path. And if I'm not there to say, hey, that's not right. So there's a couple of different ways you deal with that. When I'm dealing with a human being, like presumably you are a human being and not simply some thing, I see it and I correct it. Well, it's not dissimilar when I'm dealing with an LLM. First of all, I have to be careful in how I design the process of building this context that I'm feeding it. Because if I put in garbage, if I put in vague things, then I get then I get the wrong thing out. The second thing you sometimes do is you put in some testers. You can have like two different processes going on that check against each other, you know, and one might be doing just as I would do with you, something like, I got this result back. This is the question I asked. Is this consistent? And it'll go match it and see if it's consistent, and so those are different tools you have to correct these things. But it's not like some drug-induced, equivalent of some drug-induced fantasy. It is simply, I have this enormous correlation machine, and it's correlating the wrong thing because I wasn't careful.
It's not like you're thinking of Bertha, but they're playing Fire on the Mountain. It's not that type of hallucination.
Now, that's interesting. Well, given that particular example, no, it's by definition not that kind of hallucination. because you're not passing out buckets of LSD before you go. And even if they did, your average LLM doesn't respond to that.
That's right. Okay, I will bring up another often used phrase. In keeping with your example of communicating with a human, if you say something that doesn't that doesn't keep my ADHD in check, I might drift.
Mm-hmm.
So there's a drift capability or risk with an LLM. Talk about that. And what is it?
It's not a dissimilar thing. Again, remember, the LLM is a relatively passive component here. It's a very complex component, but it's relatively passive. Mm-hmm. It's being completely driven by the agent. So the agent may have a dozen cycles of iterating with the LLM to produce a single result. The first thing might be, here's an event that just came in, and here's some information about it. Here's a list of all the tools I have. LLM, look at all this and tell me what to do next. Then it will reason. You've given it everything. It's not making it up. You've given it everything, and it's coming back is based on that. You should query this database. So you do that, you dump it in there, and you do another cycle. And you're doing this iteratively. So if there's drift going on, you should be able to catch that because you're iterating. So first of all, if you're careful and you have some checks against, yes, we're continuing to use the tools I have, the context is evolving in a meaningful way, you're not drifting. If it starts to drift, then this is where you have these secondary processes that sort of observe this each time and say, is this consistent?
And give an example of what drift could look like for listeners that may not be familiar with that term.
Well, so if I go and say, do a Google search, and I come back with a bunch of stuff, and then from that it says, do another Google search, which is not really the right Google search, and you start going off. So first Google search is, well, look up Ed's bio. Oh, okay, here's Ed's bio. Okay, because the original question was something about something about your hometown. I don't know. You're making this up. It probably won't be a good example.
No, it sounds good. Keep going. Yeah.
Well, I do that, and it comes back, and I didn't quite say hometown correctly, so it picked some other town that you were involved in to say, do a search on that, right? Because I didn't phrase it right. It didn't give it the information it needed to say, oh, we're talking about his hometown. It doesn't say it was hometown in there, so I have to think of where else you can search based on the information you gave me that might give me his hometown. And I come back, instead of, Boston, I come back with Indiana because you went to school in Indiana. That might be an example. And I don't catch the fact that we've gone off topic here. I could get a wrong answer.
So like a query rabbit hole, if you will.
Query rabbit hole. And I have to design against that. I have to design to prevent that. I shouldn't ask questions that have the potential for drift. I need to be careful about how I nail down what's going in so that it's not ambiguous, because ambiguity is your enemy here, right? It's true in general, but, the good news with these tools is we can make leaps, referential or inferential leaps that we couldn't do without them.
Mm-hmm.
The bad news is that if we don't control the launch pad for that leap, we could land in the wrong place and continue from there. And, there's no human being in there to say that doesn't look right. You can build these secondary processes, where you have another cycle that's observing what you're doing and that's trying to detect that drift. But mostly it's just good craft. It has really nothing to do with the LLM. It's just consider how you're using it. There is the opportunity, since you're using it to inference off of what you're giving it, it doesn't know. It can go in the wrong direction.
Once again, humans are the weak link.
In this case, engineers. We engineers are always the weak link.
Okay, so here's the next question. Will there ever be a period of time where humans are no longer the weak link because we're no longer needed?
Okay, so
is AI going to take over
one of
the
the things I
world?
write about a lot. There is a potential for an issue here, but there's also not so there's a meme that has arisen in where I live in Silicon Valley. I don't know how common it is out there about superhuman AI and how that's going to arise. And again, I go into this in a great deal of detail in some of the articles I've written. No. The short answer is no. You're misunderstanding what this thing is.
So I don't need to look up Sarah Connor. I don't need to go find her right now.
Okay. Well, let's just say that the current raft of technologies doesn't have any visibility into building a Terminator. What it does have is the ability to drive automation at a level that is an order of magnitude, or I don't know how much larger. It dramatically improves the level of endeavor that you can automate.
Mm-hmm.
Well, it turns out that we human beings were not originally intended to be specialists, but for the last 10,000 years ago, we've gotten more and more specialized. This is the nature of civilization. And the problem is that with these new technologies, almost any specific task, specialization, can be automated. Some are harder, some are easier. So we're going to have to learn how to not be specialists if we're going to have relevance. Because any, narrow, well-defined task in almost everything we do is like that.
Is ripe for AI.
Now, in some cases, there's machinery that has to be built to allow that if the specialization is, picking some particular crop, well, that requires some pretty fancy robotics as well.
Clean my shower drain.
Or clean your shower. Well, it has.
Kill the aggressive wasp nest.
That may be the last thing that we find automated, just because.
Okay, so plumbers become a plumber, become a bug guy. Those are jobs.
Those are hard things to automate because there's so many variations of it. But if you're picking one particular kind of thing, well, maybe you as an individual can go pick something else. But each individual kind of thing, I don't want to pick on the pickers, but that can be automated. That and it will be automated. Any kind of manufacturing that that's already been happening, and it's going to pick up steam. Accounting is largely an exercise in specialized operations. It can be automated. And these tools advance the level of automation possible dramatically because they give more flexibility.
So be a dreamer and a poet in the future.
If you can, then the challenge for us as a species is to figure out a business model that allows that to be a worthwhile thing to do from an economic standpoint.
That's right.
So that's the concern I have. It's not Terminator. Yeah. I'm not worried about Terminator killing me. I'm worried about not having something to do that is economically viable.
Got it. How'd you get into IT?
Well, in my youth, I thought I was going to be a physicist and philosopher.
Okay, now we're talking.
Then I got to the university and discovered what physicists actually do, and thought, maybe not. And And I also started realizing that philosophy is not much of a place to make money.
That's
And
true.
it turns out I've always been taking things apart and then putting them back together again, hopefully in more or less the same way. And it turns out that lends me towards being an engineer. So at some place in my early college career, I subtly switched from physicist philosopher to engineer.
Did you ever read that book, Sophie's World?
No,
Philosophy.
no, I did not. I will put it on my list of things to do.
It's a really interesting story, yeah.
So I am a philosophical engineer, which is why I write articles on pragmatic AI, because if you're a philosophical engineer, that's what you do.
I could code this, but I can't.
Okay.
Sorry.
I didn't understand. I have bad jokes. I am known for bad jokes.
That was terrible.
But I could take a lesson from you.
Sorry. Maybe we'll cut that one out.
No, please don't. Because,
All right.
Because after that, any bad joke I make is going to shine.
What keeps you up at night?
Well, I do worry about the automation thing. I don't know if that keeps me up at night.
Mm-hmm.
I do worry about that. I always worry about, well, I have this understanding of how things work. What if I'm wrong? That's a personal insecurity, you know. I place a lot of confidence in my understanding of how things work.
Mm-hmm.
What if I'm wrong? So that certainly keeps me up at night. That's personal stuff, you know. But
Are you often
for the
wrong?
most part, I actually do sleep.
Are you often wrong?
I am. How can I answer? I am sometimes wrong in detail. I find, rarely wrong at the macro level. Except when it comes to like personal relationships, when I'm almost always wrong.
It's people again. It goes back
It's those
to
damn
Soylent Green.
Yeah.
I think I've overused that joke too many times on this podcast. All right. What are your top 3 priorities over the next year?
So, well, first of all, I'm building a fractional CTO business, which it turns out if you accidentally discover that you're a fractional CTO, you suddenly have a responsibility to keep that going. And I kind of got into it, as I said, by accident. I just sort of looked around one day and all these things had fallen in my lap and you can't keep doing that. So that's certainly a priority. This theme of helping folks to understand what this new technology is and isn't is a big deal to me. I think I have a book in there somewhere and I'd like to get that done in the next year. But as a minimum, I want to continue to get clarity on that and write about that. So that's a priority for me. Is there a third priority? Try to have more fun.
That's so hard these days, isn't it?
It can be. You get things get obscured. But yeah, I'd say those are the things.
Nice. I think you should call it Fractal CTO.
I delved into fractals in my past. I am as fractal as they come.
I knew you'd get that. All right.
Chaos is everywhere. Risk may never sleep, but chaos is everywhere.
Entropy requires no maintenance.
Ooh.
Okay, here we go.
So when are we going on a stand-up
I know.
Bad humor stand-up tour?
I'm not sure many people would be there. That's the problem. All right. Riskiest thing you've ever done.
Laughing, we'd get a constant.
Yeah, I know. We'd get a. Yeah. What's the riskiest thing you've ever done?
Ooh. Physically, I mean, at startups, I've been in risk my entire career.
Yes.
Probably the first startup was that. But if I had to choose one thing,
what was the first startup you were in?
So it depends on what you call, but I joined I shouldn't say this because it's giving away my age, but I joined my first startup in 1985.
Oh, good.
And it was my first true startup. I was the third employee. There's a couple of companies before that earlier in my career. And again, I'm telling you a little bit too much here there, that when I look back at them actually were kind of startups, but I didn't understand it at the time. But the first explicit one was in 1985. I was the third person. It was an enormous learning opportunity. I mean, I was forced to transition in so many ways into a, shall we say, more mindful, broader thinking individual from a pure geek. Learned some incredibly hard lessons in that, and then proceeded to co-found when that one failed and I couldn't let go of it, I took the founder of that one and some other folks and co-founded another company.
What was the technology, or what was
so we were building a very interesting graphics workstation.
Like Silicon Graphics.
Kind of like that, because that's what one did at the time.
I remember.
This particular one had elements of HTML interpretation in it, which was like 10 years ahead of
Really?
Yeah, I mean, we were modeling documents much the way you think, if you think of HTML and you can render it and process it, interpret it in a variety of ways, right? And that's
Was
what this graphics workstation was capable of.
Was it using TEK? TEK? Do you remember that language?
No. We actually built our own document markup language.
You did?
Well, yeah. I mean,
that's cool.
I mean, understand, this was a time when if you're going to build something like that, you didn't just buy a machine and program. You had to build the machine.
Now, we're using Unix or using VMS?
Neither. We actually used an IBM PC as the front end to our graphics processor, which was a bit sliced, micro-coded engine with its own. I mean, again, this is what you did back then. You built the engine, you micro-coded the engine, the microcode defined a language, and then you programmed it in that language.
That is cool.
And that's what you had to do back then.
That is cool. So, did you play D&D? Come on.
I've never been a games person.
Never? Not even Atari?
Never. Oh. So I have not been that kind of geek.
Okay. If you weren't doing this job, what would you be doing?
What would I be doing? Hopefully writing. I like to write. I have other things besides AI that I'd like to be writing about.
Like what?
Well, this is tangential to AI, but I write on a variety of subjects. I write on politics. I write on some philosophical subjects. I write on history. But there is also a notion of consciousness and what it actually is that comes up in the context of AI, because one of the problems you see when people talk about superhuman stuff and things like that is they're using terms they haven't defined. And one of my favorite things, or least favorite things, is, well, the word intelligence itself has never been defined. And you ask somebody, so what's your definition from intelligence? And they start defining it in terms of human intelligence. And right away, you know, okay, they don't understand what they're talking about. They may understand the AI technology, but they really they're making claims against a term that they haven't thought through. And it's even worse when it comes to consciousness. What is it? I think I have some things to say about that.
Where are you published on Medium, or where do you
I also publish on Medium. So most of my technical articles are on LinkedIn. So if you want to read about AI, go on LinkedIn.
I want to read about your consciousness work.
Well, I haven't written as much of that, but there's some of that on Medium.
On Medium. Okay, I'm going to look for that.
Okay.
All right. You ever hear of the fourth wave?
I don't write under a pen name.
Did you ever hear of the fourth wave, or do you know any of the movements around consciousness at all?
There's a bunch. There's the physicalists. There's the panpsychics. I think they are all failing. So here's what happens with me. I am an engineer. I approach everything from an architect as an architect, technology architect and engineer. So if you want to understand consciousness, to me, and we're going off on a tangent here, you have to understand a concept called abstraction. And that's where I'm starting from. Because until you understand the way a complex system like your brain or this computer is built on layers and layers of abstractions, you don't have any real appreciation for the relationship between what you're experiencing and way down there, anything that's real. Because you have all these layers between you and that are essentially lying to you, because that's what abstractions do. They are useful lies, and you build on them, right? So, one of the useful things about having started in technology, the one I did, is that back then, if you wanted to learn to build anything digital or build any complex system, you started by learning semiconductor physics. And the first great lie is called a transistor. And when I found out how a transistor worked and started building up from there, the layers and layers of make-believe that we use in order to hide complexity and allow us to build more complicated systems, and you build the 100 additional abstractions on top of that to get to what happens when you touch a computer, you suddenly realize you have no idea what's actually happening, what the reality is that's underlying the experience that you have when you operate a computer. Well, the same thing is true with your brain and whatever is out there outside of your brain.
We're in a hypnotic waking sleep.
I suppose you could argue something like that. I think so much about that is understanding what are the right questions to ask.
Yeah, I love it. Share a fun fact about us that many people don't know. Or I'm sorry, share a fun fact about you, not us. That would be weird. That many people don't know.
Ooh, interesting. A fun fact that many people don't know. Trying to think of things that people don't know about me. I am an insane foodie, an insanely adventurous eater.
Okay.
I am quite sure that I've seen, how in some movies they talk about having seen your death? I'm going to die someday in some obscure village in some, in some outskirts of India, eating some street food that I shouldn't have come anywhere near.
Like spiders, larvae or something. You're on a desert island. You could bring 5 albums, and I know you know what albums are with you. What would they be?
Well, so that's the last thing I saw somewhere that you might ask that question. I got to say, it's the last thing I would worry about on a desert island.
You have an unbelievable sound system on this island.
But, if I had to, so my practical mind is saying, okay, albums. I'm more concerned with what they're made out of, because I want that to be useful. So I'm thinking, okay, I want the masters that are made out of nothing.
Okay, you get the masters. Okay.
So that I can carve them into tools.
Okay, double.
How's that?
But which ones? Which ones would they be?
So I have to tell you, my musical tastes stopped evolving sometime in the late 1980s.
That's good. Okay.
Then
I may want to be on your island.
My kids tried to keep me more current than that, and that worked for a little bit into the 90s, but then they got bored with doing that, and I just haven't evolved since then. So it would be probably 60s and 70s and 80s, some collection from that.
Okay. Were you a Zeppelin or a Stones fan?
I resented. So first of all, I was Grateful Dead fan.
Oh, there we go.
More than a Zeppelin or a Stone.
Awesome.
Grateful Dead, Jefferson Airplane.
Ooh, Surrealistic Billow. Nice.
Things like that.
The Doors?
Oh, of course. Of course.
Excellent.
I suppose some Led Zeppelin more than, what was the other one you mentioned?
The Stones.
Yeah, Led Zeppelin more than the Stones.
Okay, very good. All right.
I don't know what that's going to tell your viewers. Other than that, I'm old.
Yeah, that's
Now, okay, so just so you know, I'm 39 years old.
Your AI, well-preserved AI.
So, we'll leave it at that.
You look great. All right. Last question. What advice would you have to a newly graduating student that wants to get into IT, that wants to get into AI?
So this is a peculiar time for that, and this is a concern. This, you hear a lot about how these tools are going to eliminate software engineers.
Yeah.
They're not, at least not. They're not. But what they are going to do is make entry-level positions less needed. Because the hard stuff, I still need a senior engineer to do. The easy stuff, I just code it up. I just, you just ask the question, it comes back with some code. You don't just use that code.
So many tools.
But the tools are now at a point where all I have to do is, I can get a raw basis that I can very quickly turn into the real thing very quickly. And it's getting better and better. And so that's what I could use junior entry-level engineers for, is all those tasks that are, here's an example. I need 6 more like this that are slightly variant. Please go do them. I don't need the junior engineer to do that anymore. That's a problem, because what do?
What do they do?
At some point, those junior engineers were expected to mature into senior engineers. So in 10 years,
you're not going to have senior engineers.
A gap in that skill set that is still going to be needed. And I honestly don't have an answer for that.
Interesting. Well, I wonder if the tech gets to a point where the need for as many senior engineers goes away.
I mean, it's hard to say 15 or 20 years what else will happen. This current crop of tech is really creating a greater need for solid engineers at the moment. Not a lesser need, because it's complicated and it's engineering. And the kinds of things you're engineering require some experience, because you're building sophisticated data models to support context building, and that sort of thing. And that's not easy. And so those folks who are good at that, they're going to have a lot more to do for a while. Yeah, I can't say what will happen in 10 years. I mean, things could get disrupted in all kinds of ways.
Who thought 10 years ago we would be where we are today with AI, right?
Yeah. I mean,
AI has been around forever. Bayesian logic, Bayesian inference.
So let's
been around forever, right?
Let's touch real quickly on the history of AI.
Yeah,
I started in AI with Marvin Minsky at MIT.
Oh, okay.
And at that point, it was philosophy, a computational model of mind. It was in fact philosophy. Nothing like what we're talking about right now. So in the 90s, AI was expert systems, which were rule systems. Nothing like what we're talking about right now. Neural networks became more viable. They've been talked around since the late 50s, but they became more viable in the early 2000s. You saw machine learning, right? And that started to be called AI for a while. Maybe not. The term AI was not as heavily used. It kind of regained its cachet with the introduction of the transformer architecture, which enabled generative models to become, and these very large inferencing models to become viable.
5 years ago or less.
So 2017 was when that seminal paper was introduced. So about 2018, 2019 is when they started becoming seriously there. So it's 6-7 years that we're talking about that this latest crop has been around. So it is pretty new. And it has been transformational because of the scale, because it becomes possible to train something usefully on semantic information at a huge scale and produce results that are this feedback loop. Remember, I told you the iterative way that agents use it? It's not really possible with machine learning because it just produces a prediction, produces a number, something like that, a curve. you can't really iterate on it. It does one thing and it does that.
Mm-hmm.
These things are now more open-ended, and you can iteratively interact with them. And that's a whole different model. And it's going to take us, 5 more years or so to really mature that style. And of course, things are the underlying technologies are getting somewhat better, but what's getting better faster is how quickly engineers are learning how to use these new models in a pragmatic way. So I forget what the original question was, but that's a little history of AI that you can put that in context. And so, this technology will plateau, I think, in 5 years, but there may be another radical change.
Interesting.
I wouldn't have predicted the transformer architecture, before it showed up.
Well, the true change will be when we can fuse what we have today with what we have here.
Well, so there's different directions that you can go. And I think the future of humanity personally involves a deeper integration. You can't just ignore these tools. You have to integrate with them and turn them into extensions of what you do.
Mm-hmm.
Otherwise, you have rampant automation with nothing better in sight.
And I think that's when there's an opportunity for the Terminator scenario, because now you're going to have a scenario where some people will get the integration and others won't.
So I don't want to get into my dystopian dreams.
Yeah.
But there is a dystopian path that could go.
Yeah. Well, because it's people, Keith.
Because it's people.
We're our own worst enemy. We screw it up all the time.
And we have this vast economic infrastructure that has evolved ever since the agricultural revolution, right? That is all based on a certain distribution of function, shall we say.
Yes. Yeah.
And that's what gets disrupted by rampant automation.
Right. Those that have and those that don't.
What replaces that as an economic model is a very interesting question that I don't have an answer to.
And that's the question we ought to answer, because if we answer that question, then we can sort of back into all of the anxiety that's being produced right now about this.
It's really about economics. It's not about deciding to.
It's always about economics.
Well, I mean, in the Terminator model, it's about a supermind deciding we're useless ants and crushing us. I'm not worried about that. I am worried about breaking an economic model that humans have relied on for their entire history as a civilized, for the entire history of civilization.
Yeah. Yeah. Well, economics isn't just money. It's also agency.
They are directly.
So in the Terminator scenario, wasn't about money. It was about the agency.
Okay, fair enough. Fair enough.
Anyway, and we're going to leave on that because I sound really damn smart, Keith. I have no idea where that came from. Every now and then.
I am impressed. I am impressed.
Every now and then a blind squirrel finds a nut. So. This is Ed Gaudet from the Risk Never Sleeps podcast. And if you're on the front lines protecting and delivering patient care, remember to stay safe and vigilant, because risk never sleeps.